I am audible. Good. संजय सर मेरी आवाज आ रही है आपको?
Yes, yes, coming.
Okay.
I can hear
So,
you.
chief guest, speakers, faculty members, researchers, students, and participants. A very good evening to all. Welcome to the day 9 session of Agri Excel 4.0. 21-day national training program. It is our privilege to welcome Professor Sanjay Swami, Dean, College of Agriculture, Pasighat, and an eminent expert in soil science and agriculture chemistry with specialization in soil testing. We are honored to have you with us today and look forward to learning from your valuable knowledge and experience. A warm welcome to you, sir. Thank you.
Okay, shall I start?
Yes, sir. You can start now.
Okay, okay. Thank you so much.
Okay.
Uh,
Welcome.
Very good evening to each and everyone present on this platform today. Friends, I welcome on this 21 days summer school program on sustainable agriculture and smart farming innovations, which is being conducted by Meadow Agriculture from 9th to 30th of June 2026. Uh, okay, so without wasting much time, I am directly coming to the topic. And for today, the topic assigned to me is soil testing. So let me share my slides. So I hope my slides are visible.
Yes, sir. Slide. Please.
Okay, okay. So let me go for slideshow. I am facing some problem. It is not properly. Let me share again.
So before the slides was visible.
So is it okay? My slides
Yes,
are
sir. It is
visible.
okay. Yes, sir. Your slide is visible. Please continue your session.
Okay. So friends, the topic assigned to me is soil testing, and you know that. Let me give some brief history. At the time of independence, when our country got independence, at that time our production potential of the varieties that was very low, and because of that we used to go outside, or we used to import food grain, particularly wheat and paddy. And for that reason, uh, India is considered as a beggar. But at that time it was realized that we must increase our production, and for that many new varieties has been introduced, has been developed, which are of having high yield potential. Now the thing is that when we are producing more, then definitely the varieties which are producing more, that require more nutrients, and the nutrients is coming from the soil system. and that's why there was urgent need to develop fertilizer industry, and the fertilizer industry has come up. Now the thing has happened like this, that because of these easy available nutrient source in the form of fertilizers, the farmers, they used to means apply fertilizer, but in the long run they forgot the organic manures completely. And what has happened, because the fertilizer granules or the
Sorry
fertilizers.
for disturbance. Your slide not moving, sir.
I am still on the first slide.
Sir, slide not moving.
Yeah, I am still on the first slide, but yes, some problem is there. Let me check it.
Okay. Not problem, sir. Please send me the slide. I will present it and you can continue. Sir. And your PowerPoint version is not activated, sir. So slide not moving.
Why it has happened every time I am presenting and there is no issue? Why today it is happened like this? Okay, where to send these slides?
Okay. My WhatsApp number, sir. I will
Okay, send a message. I will share.
just wait, sir. I will send it.
Hmm, okay.
Sir, I will send it the message. Please send me the PPT.
Yes, yes, yes. I am waiting for your message.
Sir, my screen is shared. Sir, my screen is visible.
Not yet.
Yes, sir. So please continue.
No. Okay.
The screen is visible, sir.
Yes, yes, yes. It is visible now. So, friends, because of that reason, the fertilizer industry has come up, and in the long run, the farmers they forgot completely adding organic manures, and because of this continuity of this non-addition of organic manures, the organic matter content or organic carbon content of the soils, particularly in India, has declined. And now we recommend soil testing. The main purpose of soil testing is to make good fertilizer recommendation. How much nutrients we need to supply. For making those recommendations, we need soil testing. And it is just like our body testing. Whenever we have some health issues, we are going to doctors, and the doctor is advising different type of maybe blood test, sugar test, and all different type of tests. In the same way, if we need the exact information regarding soil fertility status of our field, we need to go for testing. And the testing is nothing but this is a rapid soil chemical analysis which provide the status of available nutrients, and the basic purpose is for making recommendations. Now there are four major parts or four major steps which involved in soil testing. The first and foremost is soil sampling. This is the basic thing. Without a representative, a proper soil sample, the whole things or the next, all the steps that are, you can say this completely waste if we are not following the uh, proper collection of good soil sample. Then the second is processing of the soil sample or preparation of soil sample. And the third one is soil testing or extracting the nutrients by different you can say the extractant which are suitable for different element. And the last one is the interpretation of the soil testing results. Now again, this slide shows that the soil testing is not useful without meaningful samples. As I just shared with you people, that if the sample, suppose you are giving blood sample for testing and your blood sample is taken in the wrong way, then the analysis is completely wrong. Likewise, in soil testing, the basic unit is soil sample. If your soil sample is not representative of your field, then the whole process is wasting of resources, wasting of money, wasting of chemicals, but nothing will come out. Then next is that apart from making recommendations for fertilizers, there are certain other objective of soil testing. So the next, you can say, the objective is to find out certain problems associated with the soils. That may be soil acidity, that may be soil salinity, that may be the calcareous soils. Previous slide, please. Previous slide, previous slide. Are you getting my voice?
Yes, sir.
Go to previous slide. Let me complete that. Next one.
Sir, this slide and any other slide?
No, no slide is next one, next one. Yes.
Next one.
Yeah, bus. Okay. Okay. So the second objective I was telling about is there to find out the specific problems which are associated with the soils, and third one is Yes, the third one is that if we want to go for a specific crop, whether our soils, our field is suitable or not, that we can identify. And apart from this, if we want to go for orchard plantation, then our soils, our field is suitable or not, because for that purpose we have to go to the much deeper soil analysis part. And likewise, we can calculate the nutrient indices like this N, P, K, and we can develop the soil fertility map also. So these are some of the other, you can say, the objective or purpose of the soil testing. Next, please. Yes. Now coming to the time of soil sampling, what will be the time of that is the question of many of the farmers and many of the persons who are not knowing. So friends, the soil sampling can be done at any time of the year, during whole year, but the best time for soil sampling is harvesting of the standing crop and before, you can say, sowing of the next crop. So the lean period between that is the best time for going for soil testing. And sometimes if the situation arises, suppose some deficiency symptoms are coming and the soil scientist is advising that you have to go for soil sampling, that we can go for soil sampling in the standing crops also. Between the two rows we can collect soil samples. Next, please. Now coming to the depth of soil sampling, just now we have discussed that if we want to go for orchard plantation, the root penetration is much deeper. That means the penetration of root is the basic principle for deciding the depth of soil sampling. For most of the arable crops like paddy, wheat, we can go up to the plow layer, that is 0 to 15 centimeter. But if we are going for some orchard development or the plants which have the deeper root system, then we can go for the whole soil profile testing, or much deeper, that may be 15 to 30 centimeter, 30 to 45 centimeter, likewise. Next. Then coming to the different tools and techniques which required during the soil sampling, friends, we know that the basic criteria for selection of preferred tools, there are two basic things: that it should take a uniform slice, uniform portion, uniform slice of the soil, and second is that it will extract, or it will take the same volume of the soil from each area or each core from where we are taking the samples. And in this picture you can see that this kurpi, we are taking a slice, making a V notch. That means from both the sides, in every V notch we are taking a small uniform soil surface and same volume of the soil. Next. Now coming to the different soil sampling tools, there are many type of augers like this tube auger, post hole auger, then screw type of auger. So all these different type of augers that are meant for different type of soils. And apart from the different type of spades, kurpi, shovel, then many things we need like this plastic tub, cloth bag, then this marker, pencil, labels, all these things are required for proper labeling of the soil samples. So if the soils are wet, then we need this post type of auger. If the soils are soft, then we need this tube auger. So different type of augers that are available in the market, and according to the soil type, the hardness of the soil, softness of the soils, wet soils, we can choose the right type of soil auger. Next. Yes, nowadays you know that there are different tractor mounted soil sampling tools, truck mounted, then this automatic tractor when mounted uh, this soil sampling tools are also available. If we want to go for a large area, or we want to develop a new site for plantation crop, or maybe for orchard development, or large area under cultivation we want to bring, then we can go for these type of modern equipments or modern tools. Next. Now, what will be the technique for a collection of a good soil sample? Friends, the main thing that how to collect the representative soil sample, and the basic thing is that we need to assess the variability of our field. How much differentiation in our soil fertility is there in our field, that we want to know. There should be some basic idea. See, in this picture it is shown that the different areas, it is marked here. This may be one different type of area, that this may be of different type of area. So we need to sample uh, each type of unit in different soil sampling. Next. Now the thing is that how we can recognize the field variability, whether our field is having some variability or not, because based on the variability we are dividing our field in different units. So the direct indicators are that we can learn about the cropping history, how the crop is being produced, how was the harvest, then the fertilizer history, then manure history, then any old homestead or old feedback feedlogs. All those things, they are the direct indicator, because if we have applied some fertilizers, then definitely that particular fertilizer which nutrients are being given, and fertility may be high in that particular nutrient aspect. If we have applied organic manures also, then definitely there will be a good nutrients availability. And there are some indirect indicators also, like this topography, then aerial photos, soil maps, yield maps, soil electrical conductivity. These are some of the indirect indicators. So see, if the topography is irregular, uneven, somewhere the field is having height, somewhere it is depressions, then definitely there will be the variations. So these are some of the variation. Based on these variation, we can divide our field to do sampling as a different entity. Next. Now the main thing is that sampling by soil type is the best choice. If we have different type of soils, then we should go for different type of you can say the division, from where we can collect samples in a different patches. And this type of sampling, which we call as zone sampling, or it is superior than the random sampling. I will tell you the different type of sampling also. We have random soil sampling, we have stratified soil sampling, and we have grid sampling. So in nutshell, you can see that random sampling, just we are taking samples from the randomly. And in stratified some sampling or zonal sampling, we are dividing the field in different type of variations in fertility, and that is more suitable for the larger area. And grid sampling is most suitable for the fields where the variability is unknown, but we want to predict that variability at a suitable intervals. Next, please. Next, please. Next. Yes, these are some of the sampling types. Just now I was discussing that this zone sampling or stratified sampling, This is more means accurate or useful, where we have to sample the large area, and the field variability is you can say that the farmers who are having the knowledge about variations in their fields. And grid sampling, when we want to means sample uh, or know the variability which is right now not in our knowledge, which is very much means you can say that in grids we have a different interval of spacing, that this type of interval we are taking, and in that interval particularly if there is some variation, that we can know by the soil sampling or testing. Next. Yes, these are some of the, you can say, the examples of grid sampling. Within grid sampling, we have composite or cell system. See here, these are some of the grids, this grid, and within this, if we are taking composite sample from different points, so that is called composite or cell system. And if in grid system we are taking sample from different points like this, then it is called grid point system. And here we assume that apart from these points from where we are taking samples, the rest of area, that is also same type of area. That means we can assume that these points from where we are taking samples can represent the unsampled area also. Next, please. Yes, these are again filled composite, then stratified composite, and grid composite. Here you can see this is one field, and if we want to take composite sample, so there are different. This is random sampling. This is again grid point sampling, and that is zigzag sampling. Likewise, in stratified, we have two fields. Again, the random sampling, then again this uh, zone sampling or grid sampling, and this is again zigzag sampling. Likewise, in the grid sampling also, we have the points, this random sampling, then we have point sampling, and then we have the composite grid sampling. Next, please. Now the thing is that which method is best suitable for which type of soils. Again, here I have mentioned that the random or whole field sampling is most appropriate when the existing fertility is high and variability is low. That means we have good soils of fertility, but the variation in the field is very, very low. Then we can go for random sampling. But for this zonal sampling, the location is variation is already known. That I am saying that if we have already known variations, then we can go for this zonal sampling. And in this technique, if we have large area, then it is most suited one. Then in grid sampling, again, the same thing, that it is most appropriate when the location of variation is unknown. That I am saying that if we want to know the variability, where the field variability is right now, that we want to predict, then we can go for this grid sampling. Next. Now, again, the thing is that these are the some of the methods, but how to take a good sample. So first thing is that decide on sampling, right type of tool, right depth, and how much number you requires, and what is your location. Then you take a clean plastic tub, and of course, you can just put a oil or a coat of some of wax, which will be just, you can say, the easy to just extract the soil samples from your this auger. and you need a GPS for mapping the locations. Next. Now the thing is that first you have to inspect your field, and you have to divide your area, your field, in different variability. Suppose some of your area of your field is at higher elevation, and some there may be some depressed area, there may be some blackish type of soil color, there may be some light type of soil color. So according to different type of variability, which are indicators, that may be direct indicator or that may be indirect indicator. Based on those variability indicators, you have to arbitrarily divide your whole of your field in different patches, in different units. And then from individual field, you have to take around 15 to 20 individual soil sample or soil cores, and then you have to mix it properly and have to make a composite soil sample and bring it to the laboratory. Next, please. Now, there are certain areas, if we are including those areas in our sampling area, that is not good, because our soil samples will give inaccurate results. And you know that some of the border areas of our field, if we have some, you can say, the piles, some store of fertilizers, heap of manures, some, you can say, the uh, old fertilizer bands, fencing areas, animal paths, animal excretion areas, all those areas, because those areas, if we are sampling from these points, they can create error in the soil samples, because that will be not a representative soil sample. Next. Now, after collecting soil samples, what we have to do? We have to means the individual cores which we have collected, that we have to collect in the bucket or in a plastic tub. We have to mix all these soil mass, and then there is a process that we call quartering. We have to reduce this soil mass to half an kg. First we have to mix, then we have to make four part of this. Two we can discard, two we can keep. Then we have to again mix these two parts. Again that same quartering process we have to do, and this will continue till only half kilogram of soil remains. So that is the, you can say, the right volume which we need for soil testing. And definitely if the soil is wet, then we have to uh, fill in plastic bags, and we have to label it inside and outside, means both sides. Sometimes whatever we are marking in the inside soils, because of the soil moisture, that slip or that paper may be destroyed. So in these conditions, the uh, labels which we have marked outside with the permanent marker, that will help in identify our proper sample. And of course different depth, whether it is of 0 to 15 centimeter or 15 to 30 centimeter or 30 to 45 centimeter. So depth, location, name of the farmers, date of soil sampling, depth of soil sampling, all those type of information we have to properly mark on the soil sample, so that we can easily identify the soil sample. And then we have to bring all these soil samples to the laboratory for analysis. Next. See, here I have tried to show again all that process. See, this is one field, and based on the variability, we have divided this field, whole field, in four parts. And then we have taken this random sampling in zigzag manner, so that the whole of the field can be represented in the soil sample. And the process is, if we are not taking from the soil over, then we can make a V notes and take a uniform slice of the soil. Otherwise, for larger area, this soil auger is the best tool for taking soil samples. Next. See, this is one of the, you can say, the area where we have upland, and you can just see that this is the flat area. Here we have some, you can say, the upland type of things. Then here again depression, it is downwards, it is moving. So this is generally you can observe in the hilly areas where we have hill slopes. So this entire area is divided in different, you can say, the fields, like field 1, field 2, field 3, field 4. And in all these 4 fields, we have taken different sampling points. Like sample 1 we are taking from here, from sample 2 here, and this is the depressed area from where we are taking sample differently. Likewise, this is, you can say, the low lying areas, and from each areas here just it is shown that we are taking this random sampling in zigzag way. That I want to just convey that based on the variability of the field, we have to divide our field in different units, and then the individual unit is to be soil sampled in differently, and from each of that unit, as per our requirement, we can take 15 to 20 samples uh, from a hectare area in the required manner. Here we have shown this zigzag manner, and then we have to pull or put that whole of the soil mass at a single point, mix it well, and then by the filtering process we can reduce it. Next. So that was the, you can say, the for larger area. But if we have kitchen garden or small, you can say, the small area from where we want to take soil sample, then this khurpi is the best, you can say, the tool. Friends, first we have to just clear the thatch or mulch or grasses, but we should not disturb the soil surface. And after that, we have to take a uniform slice that may be 1 to 2 centimeter from 0 to 15 centimeter this depth. Here we have shown that if we are taking for this flow layer in the fields, then we can go up to the flow layer depth. And if we are taking sample for our kitchen garden, for lawn purpose, or for different type of garden, then we can go for 4 to 6 inches depth with the soil auger. Next. Again, the same thing, that this is showing the sample between lines in the planted crop we can take, and these are different type of tools which already I have shown. Next. This is the quartering process which just I was describing, that this is the soil mass, and likewise this we have to divide this whole of the soil mass in 4 parts, A, B, C, D. Then 2 of opposite parts we can discard, and the remaining 2 part again we have to mix. Then again we have to go for the same process. We have to divide this in 4 parts. The opposite direction which earlier we have discarded will remain with us this time, and rest we will discard, and this process will continue up to the uh, levels when we reach up to half kilogram of the soil mass. And then this labeling I have already discussed, that we have to make proper labeling with the proper information. Next. These are some of the photographs for this soil sample collection, and this drying, then processing. Next. Here you can see the variability in different type of soil. Even the color is very clearly indicating that these are samples of different soil types. Next. Now coming to the laboratory, then after taking all these soil samples to the laboratory, we have to analyze these samples from different soil parameter. We have three types of soil parameter: biological parameters, chemical parameters, and these physical parameters. Uh, for soil testing particularly, we are going for the chemical parameters, and here we want to know the available quantity of a particular nutrient, and for each of the nutrients we have different, you can say, the methods. But the extractant which we are using to extract the nutrients, that I want to explain here, that in soil testing we are not measuring the total quantity of nutrient, but we are measuring only the available quantity of the nutrient in the soils, and we are predicting that which quantity is immediately being released in the soil system. So what we are doing, we are adding some extractant to our soil samples, and that extractant is exactly removing the available content, the available nutrient part. And here you can just see that this is the extractant which we are using for the phosphorus, and when this extractant will come here, it will just mix here, and this phosphate will be removed, and this will be quantified in terms of available phosphorus. Next please. Now the thing is, which are the right extractant? So friends, uh, there are so many extractant, but some of the extractant, they extract the higher amount of nutrients which exactly are not available. Some of the extractant which are extracting the lower quantity which are exactly not available. But the right extractant is which exactly mimic the root and soil processes and eliminate the same quantity of the nutrients which exactly is in the form of available nutrient. Next. So for different elements, there are different, you can the standards extractants which are well established. Here you can see that for available nitrogen estimation, we are using this alkaline potassium permanganate. For phosphorus, we are using sodium bicarbonate for Olsen method, and for acidic soils, we are using Bray and Kurtz method. For this available potassium, we are using neutral normal ammonium acetate method. For analysis of different micronutrients, that may be iron, copper, zinc, manganese, we are using DTPA method, that is diethylene triamine pentaacetic acid. And for boron, we are using hot water method. For molybdenum, we are using ammonium oxalate method, for which is at pH of 3. Next. Now, friends, for every, you can say, the nutrients, we have some categories, because for interpretation of data, interpretation of the results of which we are getting from the soil testing, we need to assess whether our soil is good in a particular nutrient or not. And for that, we have category low, medium, and high. And there are these are the critical limits, but these critical limits also vary from location to location. But these are, I have given the general things here. So for nitrogen in kilogram per hectare, by this method, this is the range. If it is below 280, then it is low. If it is 280 to 500, then it is in medium. Of if the available nitrogen is more than 500, then it is in high category. Likewise, for every nutrient, you can just see here there is a different category in low, medium, high, and range is given. According to these, where our exact available nutrient is falling, we can classify our soil whether it is low in available nitrogen, high in available nitrogen, or medium in available nitrogen, or likewise for different nutrients and micronutrients also. Next. So based on that, after soil testing, there is one, you can say the soil test report is being generated. And in soil test report, there are two major parts which one should learn or must know about these. One is the analysis results. Okay. So based on these results, the fertilizers are being recommended for a particular soil type from where the sampling is being done, right? So the recommendation part is very, very, very important, because based on these recommendations, you have to follow the corrective measures for your field. Next. So this is all about the soil testing. This is a simple message that the soil testing is very, very important if we want to assess our field, because if we have the right soil testing results in our hands, then definitely every variety, every crop is being released with their requirement of every nutrient. That if we have a particular variety of wheat, that wheat variety requirement is already given, that it will require this much of nitrogen, this much of phosphorus, this much of potassium. And we know the exact status of our soil because we have tested our soil. So that means we can compare what the nutrients which are available in our soil and what is the requirement. So just we can check the balance, and by calculating that balance amount, we can decide that yes, if the balance amount of 30 kilogram nitrogen, so that 30 kilogram nitrogen from which source we have to supply in our field. And that is the basic things, because if without testing we are applying fertilizer, then definitely either we are applying of low fertilizer dose, that means we are not going to get good yield because of the less availability of nutrient. And if we are applying some high amount of fertilizer, that is also, at the one hand it is increasing our cost of cultivation, at the second hand it is destroying our soil, because every element with their overdose, they have some negative effects also. Suppose if we are supplying more nitrogen than the required one, so it will increase the vegetative growth instead of going for uh, grain setting. So that luxury growth or more green color will attract more insect pest, and because of the more vegetative growth, there will be losing in the crops. So there is always a negative impact of overdose also. So in both way it is harmful, and if we know the exact amount to be added, it will reduce our cost also, it will reduce cost of cultivation, it will save our resources also, it will uh, be good for our soil health also. So in that way, the soil testing is very, very important step. And you know that nowadays even the Khet Bachao Abhiyan is going on from 1st of this June to 30th of June. And uh, behind this Abhiyan, behind this campaign, the message is to save our soils, to use the balanced recommendation of fertilizer, and to save our soils. So with these words, thanks. If you have any query or any doubts regarding this soil testing, you can ask.
Dear participants, any other queries for? Okay, so no queries. Thank you very much, sir, for sharing your valuable knowledge and experience with us. Your insightful session has been highly informative and beneficial for all the participants. We sincerely appreciate your time and consideration to Agriculture 4.0. Once again, thank you, sir. Thank you, everyone, for joining today's session. Have a wonderful evening. Today's session is concluded.
Okay. Okay, thank you this Meadow Agriculture team for inviting me and for giving this opportunity. And special thanks to Dr. Khushbu because she has recommended for delivering this lecture. So thank you each and everyone, the whole team of Meadow Agriculture and the participants for their presence hearing also. Thank you.
Okay, thank you, sir. Please exit it yourself.